Okay, so the outline our today's talk will be these points. First, we will talk about the descriptive and inferential statistics, and then we will discuss importance of statistics in various fields. And the third section will be about the different types of variables, and in these types today we will discuss discrete and continuous variables. Okay, so first we will talk about statistics. What is statistics? So statistics is the area of applied mathematics that deals with the collection, organization, analysis, interpretation, and presentation of data. So statistics is related to data and the collection and organization and analysis and interpretation as well as presentation of data. So these tasks are done using statistical methods. Okay, now types of statistics. So there are two types of statistics. One is descriptive statistics and second is inferential statistics. One minute. Okay, so in descriptive statistics, we summarize or describe our observations. We have some observations and our study is restricted to those observations, and we summarize these observations or we discuss these observations. Now what we do in inferential statistics, so in inferential statistics we use these observations to make predictions. Okay, the inferential statistics is related to prediction on the basis of our observations. Okay, so these predictions are also called inferences. Okay, and prediction are inferencing about a situation that has not yet occurred. When we talk about, when we say that we do prediction, so this means that we uh, guess a situation that hasn't yet occurred. Okay, so this is done in inferential statistics. Inferential statistics generalize from a sample to the wider population. Okay, so we make generalization. In inferential statistics we make generalization. Okay, so statistics and descriptive statistics, we present, organize, and summarize data. And in inferential statistics, we are drawing conclusions, okay, about population based on data observed in some given samples, not in a sample, but given samples. So this is about the presentation and organization of data, and this is about prediction and generalization. Okay, this is the difference between descriptive statistics and inferential statistics. So descriptive statistics is concerned with describing the target population, and inferential statistics makes inferences from the sample and generalize them to the population. Okay, so one is population and one is sample. Okay, so samples are limited, numbers are limited examples that are taken from the population. Population is the whole data and samples are the uh, fewer examples from the given population. Okay, in descriptive statistics we organize, analyze, and present the data, and in inferential statistics we compare, we test, and we predict future outcome. Final results are shown in form of charts, tables, and graphs. Final results are provided in the form of probability scores. So what probability score mean? Probability scores mean that what is the probability for a given situation to occur. Now, for example, we talk about forecast. So what is the probability of rain, or what is the probability of starvation, or what is the probability of any situation? Okay, so the in descriptive statistics, we describe the data which is already known, and in inferential statistics we try to make conclusion about the population that is beyond the data available. Okay, so again, this is prediction or guessing. Tools are tools that are used in descriptive statistics are measure of central tendency, mean, median, mode, spread of data, range, standard deviation, etc. And the tools that are used in inferential statistics are hypothesis test, analysis of variance, etc. So these are the tools that are used in inferential statistics. Okay, this is again the same thing, but in other words, work with smaller data, works with large data. Process is simpler to do, process is more complex, as we have to decide on the best sampling technique. Results obtained represent the entire data set. Results obtained represent a portion of the population, but can be used to deduce information about the entire population. Error involved is usually less, error involved is usually more. Okay, now importance of statistics in various disciplines. So uh, statistics plays a vital role in every field of human activity. It helps in determining the existing position of per capita income, unemployment, population growth, housing, schooling, medical facility, etc. If we want to take decision about these things, so we need statistics. Statistics hold a central position in almost every field, including industry, economics, trade, physics, chemistry, economics, mathematics, biology, botany, psychology, astronomy, etc. Because mm, in statistic, either we do uh, uh, we perform methods related to either descriptive statistics or inferential statistics. Okay, and in all these fields we need to take decision on the basis of some statistical data using statistical tools. Okay, now in business, uh, statistic is heavily involved, plays an important role in business and decision making. We have to use statistics for plan production, for marketing. So in business, if statistical tools are used, so the profit can be maximized. And similarly in economics, so in economics, we have to deal with the national income accounts, and again, we take different decisions, and for those decisions, we need to process data, and on the base of that processed data, we then are able to make decisions. For example, supply and demand study and similar things. So for these, we need statistics. In mathematics, again, in applied mathematics, a large number of statistical methods like probability, average, dispersion, estimation, and these things are used. So statistics is also important if we are studying mathematics. In banking, so again, huge statistics are involved. State management, okay, administration. So how statistics is involved in state management? Statistics is essential to a country. Different governmental policies are based on statistics. Statistical data are now widely used in making all administrative decisions. Okay, so there is a term used as informed decision. So informed decision mean that if you have sufficient data and information, so you can take correct decisions. Okay, suppose if the government wants to revise the pay scale of employees and view of an increase in the cost of living, or statistical methods will be used to determine the rise in the cost of living, and then the pay scales can be increased accordingly. Okay, so same is the case with other fields, and natural and social sciences. Statistics play a vital role in almost the natural and social sciences. Statistical methods are commonly used for analyzing experimental results and testing their significance in biology, physics, chemistry, mathematics, metrology, research, chambers of commerce, and every field of life. Statistics is used. Same is the case in astronomy. Astronomy is one of the oldest branches of statistical study. It deals with the measurement of distance and sizes, masses, and densities of heavenly bodies by means of observation. During these measurements, errors are unavoidable, so the most probable measurements are found by using statistical methods. Okay. Now, for example, the distance of the moon from the earth is measured. Since history, astronomers have been using statistical methods like method of least squares to find the movements of stars. Okay. Now we come to the third topic, and that is variables. So samples are made up of individuals. All individuals have characteristic. Members of a sample will differ on certain characteristic. Hence, we call this variation amongst individual variable characteristic are variables for short. Okay. Now, discrete and continuous data. So discrete data is information that can only take certain values. These values don't have to be whole numbers. So discrete data is that information which takes certain values, and where we don't have any third value between the two values. Now, continuous data is a data that can take any value, and for example, height, weight, temperature, and length are all example of continuous data. Okay. Some continuous data will change over time. Okay, the weight of a baby in its first year or the temperature in a room throughout the day. This data is best known on a line graph, as this type of graph can show how the data changes. Now, I think with the graph, it will be easy to explain, because with this text, it is usually difficult to understand. Now, these are two examples. Okay, one is this one and one is this one. So this line shows time, and this shows some value at a given time, at a given time. Now, here we have first we will discuss this one. Here we have uh, time moments like time 0, time 1, time 2, time 3, time 4, 5, 6, 7, 8, and at these time slices, we have some values, uh, let's say like xn. So there, these are discrete value. There is no value between time 0 and time 1, and there is no value between time 1 and time 2. Now, when we come to this position, so we don't have discrete value. If we take time 0 and this is time 1, then we have between these two time we have a third time, and between this time and this time we have another time this, and between this time slice and this we have another time this one. So here there is no discrete points, and this is continuous, and we have continuous value. Like for example, here we have this sample and this sample, and we don't have a sample between this. But if we take this value and this value, then we have a third value here, and between this one and this one we have a third value here, and between this one and this one we have a third value here. So such type of variable is called continuous variables. Okay, same is the case here. This is continuous variable, this is continuous variable, and these are discrete variables, are discrete values. Okay, thanks for your time.